one of the biggest issues we have seen in context of whether multi-layer perceptron or CNNs is that we need to have a huge amounts of labeled data for the specific domain of images in your particular application. And it is, again, in the backdrop of the ILV-SRC challenge, I would like to commend the professors and practitioners and students in this domain who contributed to this challenge by putting a lot of effort into labeling thousands of such real-life images into real entities so that the ground data can be made available for large-scale, what we call as exploitation by the developers of systems around CNNs or deep neural networks to handle image classification tasks. It is in that background that we're also seeing the evolution of this concept called transfer learning. So you need to understand that a lot of times labeled data availability itself may be a big challenge. And at the same time, the effort also, if you require even to take a nab at doing it over thousands of images in your domain, the calibration effort is quite expensive because you have to pay to the labelers hefty amounts for their effort. And a lot of times, this is a huge challenge from a deep learning perspective. So the learning process as a result becomes very time-taking with, as you must have seen in the earlier parts of my course and even in the previous machine learning course, you must have heard that a major part of the effort in all these machine learning, deep learning courses goes into the preparation of the data, calibration of the data, labeling of the data, cleaning of the data, etc. So it's a challenge when we talk about when you have very few labeled data, how do you, optimize the process? How do you speed up learning? So it is in that context that the concepts from other areas in, software was brought in here. So, when we do software development, and I know many of you may be very, very conscious at developing large software, but in many times you will not actually go and develop every equation or every library yourself. Like say, for example, you're developing some, let us say, optimization library in machine learning or optimization library in MATLAB. You don't go and write the entire routine yourself. You go and take the library implementation of some OR technique which is present there and call it. So the notion of predefined libraries for large useful functions and reuse of such available libraries is a very common notion in software. So software reuse is a fairly common application technique in software. So the people in the domain of deep learning, especially the people who are trying to challenge the ImageNet challenge with improving the state of the accuracy, they said, why should we always have to develop ground up? Why should everyone who wants to develop a program have to develop a ground up model by labeling the entire data, cleaning the entire data, training the architecture on the entire data, etc. Instead, can we borrow from software reuse and extract knowledge which is learned from related domains in terms of libraries, and can we use that to help learning in our context where we have very few labeled data, or where can we use it to speed up learning in our own domain instead of having to do everything greenfield? So such kind of a software process is called brownfield, where instead of purely talking about developing everything from A to Z on your own terms and your own logic, you try to use the effort developed by someone as a module or a library. And it is this type of approach that is what transfer learning offers. Let me tell you, it is so powerful today that in practice, in large real life image processing CNN architecture problems of today, more than 80% of the people use transfer learning instead of developing everything by hand, like the greenfield approach, which you have studied in the previous class, where given a raw data, training test data, you develop a CNN architecture and test its effectiveness, accuracy, etc. Instead of doing that, we use transfer learning. So you can think about what I'm hinting at. Transfer learning is equivalent to reuse. If somebody who has done some effort in related domain will try to reuse.